lesson. Our topic for today is going to be chemical reactions. Remember, on our previous topic, we did what? We did compounds. And this topic is also found under the strand, matter, and materials, which consist of 33 marks on your exams, right? So now remember that this lesson is brought to you by the Gauteng Department of Education, and my name is Sianda Madlala. Let's proceed. Right, let's look at the objectives of this lesson. What you need to achieve by the end of this lesson. At the end of this lesson, you should be able to explain what a chemical reaction is. You need to be in a position to explain what a chemical reaction is. Secondly, you need to be able to represent chemical equations as models and symbols. Thirdly, we need to be able to explain the purpose of the subscript in a compound. Remember, we talked about subscript, right? So we're going to remind each other about subscript as we did in the previous topic. Right, we also need to be able to identify the ratio in which molecules react. We also need to be able to write out word equations for chemical reactions. Lastly, we need to be able to write out balanced equations in symbol form. And all this information, we find it where? From the CAPS document on page 64. Now, pre-knowledge. This is what we have done in the previous grades and also the same grade. We are going to use this as our foundation to build on this topic. So now in grade 8, under matter and materials, on your term 2, right? We have done chemical reactions. We also have done atoms and elements. And also in grade 9, which is the previous topic, right? We have done compounds. So we're going to use all of these as our foundation to this lesson. Now let's move on to the baseline activity. So for this baseline activity, I'm going to give you 2 minutes to answer the questions, right? But first of all, let's go through the questions together. Number 1 says, copy and complete the following sentences. A, the subscript number indicates the number of an element found in the formula. B, the numbers in front of the compounds indicate the in which the molecules react. Then number 2, write down the names of the compounds that contain the elements listed below. B, calcium and sulfur. A, calcium and sulfur, and B, chlorine and sodium. So you only need to write down the names of the compounds that contain the elements listed below. So now I'll see you again in 2 minutes. Welcome back, grade 9s. Now remember, let's be interactive with each other, right? We still have our WhatsApp interactive number, which is 082 760 2630. You can get us on this number. You can send us the picture for your answers, or you can ask any questions should you have one. Yeah? 082 760 2630. Now let's look at the answers here. Number 1 said, copy and complete the following sentences, right? A. The subscript number indicates the number of atoms of an element found in the formula. So mark yourself correct for getting the right answer, right? If not, write corrections. B. The numbers in front of the compounds indicate the ratio in which molecules react. Also mark yourself correct. Number 2, write down the names of the compounds that contain the elements listed below. A is calcium and sulfur. What is the name there? It is calcium sulfide. Still remember how to name what? Compounds, as we did in the previous lesson, right? We remove the last or the ending of the word and put the suffix ide. That's why it is calcium sulfide. Now B, chlorine and sodium. We said that one is sodium chloride. Mark yourself correct if you are correct. And remember to write corrections if not. Now let's move on. These are the important terms that we are going to come across as we proceed with the lesson. So it's important to grasp them so that it is easy to understand the topic. The main one here, chemical reaction. Chemical reaction is a process in which two or more substances react to form what? New substances. So you have two or more substances reacting with each other to form a new substance, right? That is a chemical reaction. So now, reactants. A reactant is a substance that takes part in a reaction and undergoes change during that reaction. For instance, if you have your hydrogen atoms, which are 2, plus your oxygen atom, right? This whole thing here means that these two are reacting with each other to form something new. So these ones are your reactants. Moving on. Product. So now product is a substance obtained from another substance through chemical change. Remember our example again. H2 plus O to form something new, which is our product, right? To form H2O. Are we together? So a product is formed after the reaction of the reactants. Does it make sense? Now, balanced equation. A balanced equation is an equation that has the same number of atoms on the reaction side and on the product side. But not only the same number of atoms, it is also the same type of atoms or same elements per compound or same elements on the reaction side and the product side. Moving on. We have coefficient. A coefficient is a number in front of the formulae in the chemical equation. We'll talk more about coefficient and how to use them. Subscript, which is the last one. A subscript is the number that indicates the number of atoms of an element found in the formula. Remember, we talked about subscript in the previous lesson. We said from this example, the 2 next to the H is our subscript. It means that it has 2 atoms of hydrogen. Now moving on. Chemical reactions, which is the core of today's lesson. So now, chemical reactions. How would you define a chemical reaction? So now, I want you to take a second, right, to write down some of your ideas. And the following words may help you to formulate your sentence. The words are reactants, products, bonds, rearranged atoms, molecules, and new compounds. For 30 seconds, let's try and formulate our own definition for chemical reaction. See you again in 30 seconds. Welcome back. Now, I hope you were able to formulate your sentence or your meaning for chemical reaction using the words reactants, products, bonds, rearranged atoms, molecules, and new compounds. Right, this is a definition for chemical reaction, right? Using my own words again. A chemical reaction is a rearrangement of atoms in which one or more compounds are changed into new compounds. Now remember to send us your responses, right? We need to hear what you have formulated using those words. Our WhatsApp interactive number is 082 760 and 2630. Now let's proceed with the lesson. Now, a chemical reaction, all chemical reactions can be represented by equations and models. As they are represented by equations and models, note that no atoms are lost or gained. They are only rearranged or simply rearranged. Moving on. Now, when thinking of a chemical reaction or a chemical formula, right? Let's look at this picture here as our example. There are three ways that you can think of a chemical equation. First of all, look at this lady here. She is thinking, right? There's some things in a speech bubble. She's thinking of the formula. She's thinking of water itself. So now, this means what? Water, a water molecule inside, let's look at the water molecule inside this thought bubble, right? It is represented as a submicroscopic representation because it uses what? Models to represent this water molecule. As you can see there, symbolic level, it uses words. Submicroscopic level, it uses your imagination. You imagine how it can be in particles. And also macroscopic level, this is what you observe with your naked eyes. Moving on, it says here the beaker of water shows what water looks like to our eyes, and therefore this is what our macroscopic representation, simply because we can see it with our own naked eyes. And I believe we have seen water before, right? The last one, the symbolic representation. We are using symbols to represent the formula for water, and the symbol is H2O. So when you think of water, you think of it symbolically, macroscopically, and submicroscopically. Right. Also, when representing chemical reactions, there are three ways of representing what? Chemical reactions. They can be represented in word equations, They can also be represented in picture equations. Not only that, they can be represented also in chemical equations, which are your symbols. Right. Let's start with word equations. So now, the word, it means we write it in words, right? So now, we write a word equation. For example, hydrogen gas reacts with what? With the oxygen gas to form what? Water. And we can write a word equation for the reaction as follows. It is hydrogen plus oxygen, it is equals to water. It is a reaction represented in the form of words. So now, on the left-hand side of this arrow, here, on the left-hand side of the arrow, we call those reactants because they react with each other to form a new product, right? So these ones are our reactants. Moving on. Now, let me ask a question. What are the reactants of this reaction? Here is the reaction. Hydrogen plus oxygen is equals to water. And here are our reactants. It is hydrogen and oxygen. But on the right-hand side of the arrow, which is this part, that is where we find what? Products. So let me ask, what is the product for this reaction? And the answer is what? It is water. Let's carry on. Now, picture equations. We're going to use the same example again. Water, right? But picture equations. How do we represent it in pictures? As you can see there, the same reaction of hydrogen reacting with oxygen can also be presented or represented in pictures called submicroscopic what? Diagrams. Here is our submicroscopic diagram here. And please note that the red circles there are our oxygen atoms and the white circles are our hydrogen atoms. Are we together? So we have the white ones are hydrogen, red ones is oxygen, and we have a product here. So it meaning what? The hydrogens react together with the oxygens to form these products here. Are we together? Right. Now, what is the product of the reaction above? What are the reactants of the above reaction? And write their formulae. Let's write the formula together. Looking at this, we have 1, 2, 3, 4 hydrogens, right? We can represent it in this way, of which I can explain later, right? Plus 2 oxygens is equals to 2 water molecules. How? This 2 H2 simply means 2 multiplied by these 2 to form these 4 hydrogens, right? Plus O2, the 2 oxygens, to form what? 2 water molecules, these ones, your 2 H2Os. Now moving on. Chemical equations where we use symbols. Right. In chemical equations, this is when we represent it in what? In the form of symbols, and it is called a chemical equation. We're going to use the same example again, right? So the chemical equation for the above reaction would be as follows. 2H2 plus O2 is equals to 2H2O. Now let me bring it back to drawings so that you can be able to make a link again. So I'm going to use this for our hydrogens, right? 2 hydrogens and another set of 2 hydrogens, right? Plus O2. The oxygen atoms are are 2 to form what? 2 water molecules. Right. Now, I guess you're asking yourself, why the different sizes, right? Let me remind you. Let's look at the periodic table. Looking at the periodic table, hydrogen here is the first element, right? And we said elements are placed according to their increasing atomicity and size, right? So meaning what? Hydrogen is the smallest. That's why on the previous slide, we have the hydrogens being small. These ones, right? And going forward, look at the element oxygen. It is placed at number 8. So it means that this oxygen is bigger than what? Hydrogen. Hence, you see the oxygen being represented as the bigger molecule. Now let's move on. Activity 1. Right. Complete the following table by identifying the different types of equations which have been shown. You simply write whether it's a word equation, a picture equation, or it's a chemical equation. So now, for 1 minute, let's do this activity. We have the equation here on the left hand side. We have another equation. We have another equation. We have the last equation. After a minute, let's meet again. Welcome back, grade 9s. I hope you were able to answer this question. So you simply needed to write whether it's a word equation, a picture equation, or a chemical equation. Before we get to the answers, let's WhatsApp each other. 082 760 2630. Any questions related to this topic, or you can send us your answers. Now let's move on. The answer here for the first equation, looking at this equation, it is what? It is a picture equation because it is represented in a form of a picture, right? The second one, it is our word equation because we used words for this equation. Carbon dioxide plus water is equals to glucose plus oxygen. The third one, it is what? A chemical equation because we used symbols to represent this equation. And the last one is also what? A picture equation. So mark yourself correct for your answers. Moving on. Now, coefficients and subscripts in chemical equations. Remember, we talked about coefficient being the number in front of the formulae. A subscript, number next to the element or the atom, right? Now, the numbers in front of the formulae in the chemical equation are called coefficients. And they represent the number of individual molecules that are in the chemical reaction. So your coefficient, it's this number that was put in front of the 2H2. This one, this big 2 here. That would be your coefficient. It is found before or next to the element. Right. For example, here we have sodium plus iodine forming sodium iodide, right? Where is the coefficient here? Here are our coefficients. Now, I will tell you a story about these coefficients. I will tell you why they are added on the next coming slides. Moving on. So when there is no coefficient, it means that there is one molecule of that substance taking part in the reaction. So meaning what? If this H stands alone like this, and there is no coefficient here, it means that there is only one molecule of what? Of this hydrogen atom. Moving on. Subscripts. These are the ones that tell us about how many atoms of a particular element are in one molecule of a compound. We talked about these ones on the previous slide, right? We said this one would be your subscript. Just to remind you, this one is your coefficient. Now, balanced equations. When talking of balanced equations, all chemical equations must be written as balanced equations. Now we are getting to that story of coefficients. You'll see. Right. Now, balanced equation, we mean that the total number and type of atoms of the reactants must be the same when you get to the products. Does it make sense? Total number of atoms and types of atoms must be the same in the reactant side and on the product side as well. Let's look at this and see if this balances. Now, count how many hydrogen atoms are on the left-hand side of the reaction and how many are on the right-hand side. And note that the white circles are your hydrogens, right? Your H atoms. Now let's count together. There is 1, 2, 3, 4 where? On the reaction side, right? Looking on the right-hand side, the product side, how many hydrogen atoms are there? 1, 2, 3, 4. What does this mean now? Let's check the following example before we conclude. Count how many oxygen atoms are on the left-hand side of the reaction and how many are on the right-hand side of the reaction. And note that the red circles are oxygen. So we have 1, 2 on the reaction side, right? We have 1, 2 on the product side. So therefore we mean that this equation is balanced because it has the same number of atoms and same type of atoms on the reaction side and the products side. So now, the following equations are balanced in the following way. So let's look at some equations and see how they are balanced, right? We see a coefficient 4, coefficient 3, and coefficient 2 in this equation. Let's read out this equation. It is Fe plus O2 is equals to Fe2O3, right? Your ion plus your oxygen forming what? Your ion trioxide, right? Now, they are balanced in such a way. These coefficients here are added to multiply the number of atoms for that element or the compound. So meaning if we have 4 Fe's, we have 4 ions, right, on the reaction side. Then you see these 2 here. This 2 simply multiplies this 2 to make it 2 times 2 is 4. We have also what? 4 ions this side. And this 2 multiplies this 3 oxygen because now it is one compound here. So this 2 here, this 2 as a coefficient affects the whole compound here. So it multiplies these 3 oxygens and it gives us what? 6 oxygens. So checking on the reacting side, we have 3 O2. This 3 multiplies this 2 and it gives us 6 oxygens. So it's simply like this. On the reaction side, we have ion, right? We have oxygen as well. Also on the product side, we have ion, we have oxygen. So for your ions, we said they are 4, right? Oxygens, they are 6 because of this 3 times 2. This side, 2 times 2 of iron, we have 4. And 2 times 3 of oxygens, we have 6. That's what we simply mean when we say this equation balances. So now the second one, 2Mg plus O2 is equals to 2MgO. Now what does this mean? It means it is balanced in such a way. We have magnesium on the reactant side, we have magnesium on the product side, oxygen reactant side, and oxygen on the product side, right? 2 times 1 becomes 2 on the reaction side. 2 times 1 on the product side, they are 2 magnesiums. O2, they are 2, right? 2 multiplied by 1 oxygen, they are 2. So these equations are balanced in such a way. Now, lesson activity again. So now this one, it requires you to study the equation below and note that the black atoms represent what? Carbon. And the red atoms represent oxygen. But note that they will not always necessarily be this color. This is just for representation's sake. So number 2, answer the questions that follow using this diagram here. So these are the questions. Again, for 2 minutes, let's engage in this activity. I'll see you again in 2 minutes. Welcome back, grade 9s. We are still waiting for your responses and questions. Remember our WhatsApp interactive number, it is 082 760 2630. Now let's look at the solutions for this activity. Number 1 was saying, what kind of representation is this? Is it a macroscopic, a submicroscopic, or a symbolic representation? And the answer is, it is a submicroscopic representation. Number 2, write a symbolic representation, a chemical equation, right, for the above reaction. It's supposed to be in this form. Carbon plus oxygen forms carbon dioxide. Are we together? Carbon plus oxygen forms carbon dioxide. Now, number 3, write the formulae for the reactants of this reaction. And the formula is simply what? Carbon plus oxygen, or C plus O2. The last one, write the formula for the product of the reaction. What is the product? The product is simply carbon dioxide, or CO2. So remember to mark yourself. Right. Let's look at activity 2. This one is quite short. I'm going to give you 1 minute to complete. Let's go through the questions together first. You have to count how many carbon atoms are on the left-hand side of the reaction and how many are on the right. Number 2, you have to count how many oxygen atoms are on the left-hand side and how many are on the right. Then lastly, you need to tell us whether this reaction is balanced and why do you say it is balanced or not. For a minute, let's engage in this activity. Welcome back. Now let's look at the solutions for activity 2. Right. You needed to, for number 1, to count how many carbon atoms are on the left-hand side of the reaction, or how many carbon atoms do we have on the reactants, right? And how many do we have on the products on the right-hand side, right? So your answer should be like this. You have 1 carbon atom on the left-hand side and you have 1 carbon atom on the right-hand side. Number 2, you needed to count how many oxygen atoms are on the left-hand side and how many do we have on the right-hand side. We have 2 on the left-hand side and we have 2 oxygens again on the right-hand side. So give yourself a tick. Number 3, is this reaction balanced or not? And why do you say so? Looking at the numbers, it should be balanced. This is why. It is because there are equal numbers and types of atoms on either sides of the chemical reaction. By either sides, we mean that there is equal numbers on the reactant side as on the product side. Now give yourself 2 ticks again. Now moving on. We're looking at now the rules for balancing chemical equations. Right. Here's the first rule here. When we balance chemical equations, we may only add coefficients. Only add coefficients to the chemical formula that are already in the chemical equation. Only add coefficients. Secondly, we may not change the chemical formula for any of the reactants or products by changing the subscripts. Meaning if you have such a subscript, you cannot change it and put 6 to balance the equation. You don't manipulate the what? The coefficient. It remains as 2. Right. 3. We may not add other reactants or products. And this includes adding single atoms of any of the elements already in the reaction of the equation or the reaction equation. Lastly, we may not remove reactants or products, but note one thing here. This is what we can only do. Add coefficients. Back to that story. Remember coefficients, the numbers next to the compound or the element in the reaction, right? In front of it. Those are the ones that increase the number of atoms per element or compound in the chemical reaction, only to balance the equation. So now, let's look at some examples on how to balance these equations. First of all, we have sodium plus iodine forming sodium iodide, right? Na plus I2 forming NaI, right? Now look at this. This is how we can balance an equation, right? I want us to work together with this one. So looking at this, you first have to compare what? The elements involved in the reaction. So on the reactant side, we have sodium, and on the product side, we have sodium again, right? Here. Now, on the reactant side, we also have iodine, and here we have iodine. Now, let's look at the number of atoms. We have how many sodiums here? We have one sodium, right? How many do we have on the product side? We have one again. Iodine, how many do we have on the reactant side? We have two. How many do we have of iodines on the product side? We have one. So looking at this, your sodiums balance, right? On the reaction side, there's the same number, and the product side, there's the same number. They balance. But when looking at iodines, on the reactant side, there are two, and on the product side, there is one. So it doesn't balance because the number is not the same. So we can add a coefficient next to a compound or an element to balance this equation. This is how. We can simply add a 2 here, right? Why 2? This is because there's already 2 on the reaction side, right? So we need to balance it to make the product side to become 2. So this 2 here is added to increase the number of sodiums, right? And also iodines. Now look at this. This 2 multiplies this sodium here. Now how many sodiums do we have? We have 2, right? This 2 also multiplies this iodine here. How many iodines do we have now? We have 2, right? Look at the iodines. They now balance. We have 2 iodines on the reactants and we have 2 iodines on the products. But look at this now. We have 1 sodium on the reactant side and 2 sodiums on the products. They no longer balance. This is because of this coefficient that has multiplied this whole compound. So we need to do what? We need to rebalance, right? Looking at this, which one is short of atoms? It is the reactant side, right? So meaning we add another 2 as a coefficient next to the reactant sodium. So these 2 will simply multiply this sodium and they become 2. Now the whole equation balances. But be careful of one thing. This whole thing here is just to help you work out and how to balance what? This equation. But your answer should be along or within this equation. Does it make sense? Right, let's look at another example. Example number 2. We have copper plus oxygen forming what? Copper oxide. This does not balance, right? Why? This is because you have copper on your reaction side, copper on your product side, and this, you also have oxygen on the products, which are 2, and you have what? You have copper on the product side, oxygen on the product side, which is 1. So let's try and balance this equation. Looking at the reaction side, your copper is 1, product is 1 copper. Oxygen, 2 oxygens on the reactions and 1 oxygen on the product. Which side does not balance? It is the product side, right? Where oxygen, and oxygen is within this compound, so we can add what? A 2 next to the compound to balance this whole compound here. So this makes 2 multiplied by 1 copper, it makes it 2. 2 multiplied by 1 oxygen, they are 2. We have to rebalance again because look at this. It no longer balances, right? So we add another 2 to balance this whole equation. So it is the same as what? The first one. Because now we have 2 coppers on the reactant side, 2 coppers on the product side, 2 oxygens on the reactant side, and 2 oxygens on the product side. Now, last 2 examples, starting off with this one. This one we have zinc plus hydrogen chloride is equals to forms what? Zinc chloride and hydrogen, right? So now we can simply add what? A 2 here next to the hydrogen chloride. Now look at this. Why a 2? Let's count. Zinc on the reaction side, there's 1 zinc, right? 1, and there's 1 zinc here. Reaction side again, 2 multiplied by 1 hydrogen, we have 2 hydrogens, and we have 2 hydrogens on the product side. 2 multiplied by chlorine, it makes up 2 chlorines, and we have Cl2 on the side. So all these elements, they balance. This whole chemical equation balances. Now moving on, the last one. Fe plus O2 is, it forms what? Fe2O3. Right. Here, the first one, let's look at this. The first one, we add what? The coefficient 2. This 2 multiplies 2 fluorines, right? It makes it what? 4. How many do we have on the reactant side? We only have 1. So it means what? We need a 4 on the reactant side to make it 4 times 1 equals to 4 ions, right? So now we have 2 times 2, 4 ions on the products. 4 times 1, 4 ions on the reactant side. But these 2 also multiplied these 3 oxygens. So 2 multiplied by 3, we have now 6 oxygens on the product side. And on the reactant side, we only have 2. So we can simply add what? A3 as coefficient, right? 3 to balance this whole equation, because 3 multiplied by 2 is equals to 6. So now we have 6 oxygens, reactants, and 6 oxygens on the product side. Activity 3, 1 minute again. So now let's go to the questions. Number 1, why can we not change the subscripts in the formula of reactants and products when we balance an equation? Number 2, write the balanced chemical equation between carbon and oxygen to form carbon dioxide. Lastly, write the balanced chemical equation between hydrogen and oxygen to form water. For a minute, let's meet again. Welcome back. We are still waiting for those answers or questions, right? Our WhatsApp interactive number is still 082 760 2630. Right. Number one was saying, why can we not change the subscripts in the formula of reactants and products when we want to balance an equation? This is simply because it will change the formula of the compound, which then represents a different compound and not the one involved in the reaction. Remember, I said this in the previous what? Lesson, that if you change the number of atoms or if you change the subscript, it changes the whole compound formed, right? Number two, write the balanced chemical equation between carbon and oxygen to form carbon dioxide. This is the balanced one, right? Carbon plus oxygen is equals to CO2, because there's one carbon, two oxygens. It balances, right? Now write the balanced chemical equation between hydrogen and oxygen to form water. This one we have what? 2H2 plus O2. This 2H2 means that there is 4 hydrogens, right? And this O2 means that there is 2 oxygens. Now they form what? 2H2O. They form 2 water molecules, which has what? 4 hydrogens and 2 oxygens. Right, activity 4. Let's take another minute to finish off this activity. Number 1. Here is a balanced chemical equation. Carbon plus water, they form carbon monoxide plus hydrogen, right? Now answer the 4 questions below that relate to this question. A. Write the formula of the reactants for this reaction. B. Write the names of these reactants. C. Write the formula of the products of this reaction. And D. Write the names of the products of this reaction. Let's meet again in a minute. Welcome back again. Now don't get tired. We learn by doing activities, right? The more we test ourselves, the more we engage with the knowledge, right? So now, number 1. Here is a balanced chemical equation. Carbon plus water, they form carbon monoxide plus hydrogen. You needed to write for A, write the formula of the reactants for this reaction. This is the formula for the reaction. Carbon and water, right? B, the names of the reactants of this reaction. And I've just said them now. It's your carbon and water. So now C, write the formula or formulae of the products for this reaction. And the formula is carbon monoxide, CO, and H2, right? Lastly, write the names of the products for this reaction. It is your carbon monoxide and hydrogen. Let's move on. Now, this activity, I want you to write it as homework, right? Now, I'm going to give you a minute to copy down this homework. First of all, you need to turn the following chemical equations into word equations. And these are your equations. A, 2CO plus O2, they form 2CO2. B, 2Mg plus O2, they form 2MgO. Then the second one, you balance the following chemical equation. For a minute, let's copy down this activity as homework. Welcome back. Right, I hope you had enough time to copy down your homework. Now, we're still waiting for your questions as we are about to move on to the lesson summary. The number is 082 760 2630. Now let's move on to our lesson summary. So right, we said that a chemical reaction is a rearrangement of atoms in which one or more compounds are changed into new compounds. We also said that all chemical reactions can be represented by equations and models. We talked about that no atoms are lost or gained in the reaction, right? But they are simply rearranged. We also said that we can think of chemical equations as what? As sub-microscopic representations. We can think of them as macroscopic representations. And lastly, we can think of them as symbolic representations. Now, this is a way of representing them. We said they can be represented in word equations, they can be represented in picture equations, and lastly, they can be presented in symbols or chemical equations. We talked about a coefficient being the number in front of the formulae in a chemical equation, and we talked about the subscript telling us about how many atoms are there in a particular element in one molecule of that compound. Now we talked about the rules for balancing chemical equations. The first rule there, which is the most important one, says we may only add coefficients to the chemical formulae that are already in the equation, but we cannot change the chemical formulae of any reactant or the products. Also, we cannot add any reactant or product. And lastly, we may not remove reactants or products. Now, I hope you have enjoyed today's lesson, right? When we meet again, we're going to be talking about reactions of metals with oxygen. So now for today, let's keep sanitizing, wearing our facial masks, social distancing, respecting others as well. Thank you.